Hey everyone, I hope y'all are having as good of a time as you really can right now. I'm Lily, and I'm going to be presenting on dense chromatin activates polycomb-repressive complex 2 to regulate H3 lysine 27 methylation. This was a study done in 2012 by Yuan, Fu et al. Let's get started. So, brief introduction. Polycomb repressive complex 2, or PRC2, is important for polycomb gene silencing, which is an epigenetic phenomenon that maintains transcriptional silencing throughout cell divisions. So, just to kind of give a little bit more background on oligonucleosomes and peptides. So, this is what you can look at for enzymes of epigenetics. So you can look at peptides or you can look at histones and oligonucleosomes. And in a previous study, they found that oligonucleosomes and histones are the more applicable portion to look at versus just the peptides. So that's why this study chose to actually focus more on the histone and oligonucleosomes versus focusing on the peptides when looking at the activation of epigenetic enzymes. And another thing to keep in mind, so one thing that this study is looking at is Drosophila PRC2. And here in this figure, you can see there's a difference between Drosophila PRC2, which this is what they are, they're fruit flies, versus human. So this ESC portion here versus the EED portion here. So these are the portions required for the enzyme activity. But you can see they are a little bit different between both. So one thing I would want to say before doing the rest of this presentation is just because these results would be true in Drosophila or later on there would be one with mice, that doesn't mean it always goes over to the humans just because of the differences physiologically and biologically. Okay, so starting here with figure 1, we are showing the 3 separate substrates and kind of just breaking them down so it's a better visual on it. So here you see the more dense substrate at the very top. So in figure 1a, the dense nucleosome array. Here for substrate 2, we have intermediate versus substrate 3, we have a more dispersed. And what that means is just different ratios of octamer DNA. And then here for portion B, we're looking at actual activation. So relative activity here. And here we're looking at substrates 3, 2, 1. And here with 1, we increase the amount of free DNA. So in figure 1b, you can see that the more dense, so which was substrate 1, has a greater activation here. So substrate 1 had greatest activation with the least amount of free DNA added to it. So here we're up here in 1A and B, we were looking at oligonucleosomes. Here we're specifically looking at mononucleosomes, dinucleosomes with a 20 base pair linker DNA. So this one, all 3 of these are dinucleosomes, which means 2. They just have different amount of base pair linkers DNA. So the first one's shortest, second one is longer, third one is the longest. So here for 1D, you can see that the mononucleosomes were poor substrates. So here we had the mononucleosome, relative activity was pretty low, versus the dinucleosome with the 20 base pair had the highest activity, and the other 2 dinucleosomes had more activity than mononucleosome, but not as much as the 20 base pair. So as the base pair linker DNA increased, we had decreased activation going on. And for this next portion, we can see that 4 here had greater activation. So the simulation fold was 5.7 when compared to the 1, 1.1, 0.8, 0.5, and 1.2. So a huge difference here. whenever we're looking at the H331 or 31 through 42 in figure 1E. For figure F, or 1F, we are examining the other tested histone methyltransferases. So you can see that although we did get a difference over here, there wasn't as much of a difference over here on this F portion. Okay, switching to figure 2, we have the H331 through 42 peptide robustly stimulated by PRC2 activation. So here again, we're breaking it up by substrates. So this is the very dense one, intermediate, and this is the dispersed. You can kind of see how spread out they are here. And whenever you add the H33142, you can see that it doesn't affect the dense ones as much, or the intermediate, but it affects the dispersed one the most here. And then as we move on to figure 2B, you can see that we're comparing the mononucleosomes versus the dinucleosomes, again, like we did here. So this is what we're looking at. So you can see the stimulation fold was 21 with the mononucleosome, and then decreased, so 3.4, 6.8, 8.8 for the dinucleosome. So it follows the same trend as substrates did. So the more dense substrate was more active before, but with this added peptide H331 through 42, the weaker ones or the less active ones get the most benefit from it. The mononucleosome got the most benefit. They had a greatest substrate stimulation fold when compared to the dinucleosomes in here. For 2C here, we're looking at, so this is showing that we're looking at the intermediate substrate, and we're looking at the simulated PRC2 activity on dispersed oligonucleosomes, but not on the core histones. So looking at oligonucleosomes, not core histones in this case. Okay, 2D, we're looking at histone H1 stimulated PRC2 activity on dispersed oligonucleosomes, but not dense oligonucleosomes. So here we have the dispersed, and here we have the dense. So when looking at the histone H1, as we added more, the relative activity with the more dispersed did increase here. And then with the dense one, it also showed increases, but not as much. Okay, and then for 2E, we are looking at histone H1 did not further activate PRC2 activity in the presence of H3 31 through 42 peptide. So here we're looking at H1, so histone H1. Here is the peptide H3 31 through 42. So what this is showing here is without and then with, without and with, without and with, and so on. And peptide H3 31 through 42. This is without, this is with, without, with. So you can look at the different activations and see that for the more dispersed substrate, we have the greatest activity with H1 and H3 31 through 42 added. But the difference between these two is smaller than the distance, or difference, sorry, with and without the peptide H3. So you can see here, it's the peptide H3 31 through 42, which is providing most of that activity. And then here, we're looking at the more dense substrate, and you can see that the greatest relative activity is present when there is the added peptide H3 31 through 42, but not necessarily whenever you add in that histone H1. So whenever you add in the histone H1, it actually decreases the activity, unlike with the more dispersed substrate. So you can see the differences between the two of them there. Okay, for figure 3, now we are looking at DOPA conjugated H3 at this point. Before I talk about this one, I want to say that this little portion right here means that it was contaminated on this band right here on the right lane. just in case you didn't know what that meant. So they were able to reconstitute the mutant PRC2 complex containing ESC and truncated SUZ12, so that's 507 to 630, which could then be cross-linked to the DOPA conjugated H335 through 42 peptide. So that's what they're showing here in 3A right here. And then you can see in 3B, there's robustly activated by H335 through 42. So if you look up here, we have a significant activation here and then here as well. Okay, and now for 3C, we have the PRC2 complex. Lost its preference towards the dense oligonucleosomes in this case. So here we have the dense, so the mutant one here, the dense is not as activated as it was with the wild type. So the mutant made the activity in the dense one decrease, while it normally would be increased, especially when compared to the intermediate and dispersed. So it had the opposite effect whenever it was mutated. And then for portion C, or D, my bad, H3K27ME3 had a significantly higher amount of activation with H3 here. So you can see with mutant activation of this right here, significantly higher. And this is again in the dispersed, and the reason why they picked the dispersed was because over here, you can see that the dispersed had a little bit more energy than the dense. Okay, now for the next figure, we have figure 4. We have, so this is upon cessation of the transcription of the CYP26A1 gene. Chromatin compaction occurred before the transformation, or before the formation of H3K27M3. So that's what we're looking at here. Let me get my notes out. So this right here is just a CYP26A1 showing the actual region that the testing primers were marked. So you can see here, the green is the regions texted for the H3K27ME3 CHIP. And then here's, so region 1, 2, 3, 4, 5, 6, 7, and 8 that were tested. And in the red were the regions tested for nuclease accessibility. So you have A, B, C, D, E. So later on in these results, you'll see that they're broken down into different regions, and that's just what this is showing, is what the actual regions are. And for 4B, this is more of just kind of step-by-step of what's occurring and how they were doing the actual study for this portion, or the actual methods behind the study. So retinoic acid is RA, and this is in mice here that we're talking about now, just so you know. So with retinoic acid, it was added 36 hours, and then the mouse cells were treated with retinoic acid. And then whenever the retinoic acid was withdrawn, this is when we're looking at. So 2 hours after it was drawn, 4, 8, 36, 72. And then, so those are the different testing times that they looked at after the withdrawal. So here we have retinoic acid. This is 2 hours, 4 hours, 8, 36, and 72. So again, that is after the actual withdrawal of the RA, or the retinoic acid. And so you can see that the relative mRNA levels decreased up to 8 hours, basically. It stayed the same after that, after the retinoic acid withdrawal. So here, this is just a continuing of the same figures, just broken down into 2 separate pages. So here are those different regions I was talking about. So I'm going to back up. So this is region A, B, C, D, E, A, B, C, D, E. So here we're looking at the nuclease accessibility index. So you can see retinoic acid has it peaking and then, or in regions A and B, as well as D and E, not and C. But 2 hours after, we have it decreasing for most of the regions. And then 4 hours after, continuing to decrease. At the 8-hour mark is really whenever it starts to plateau off. It's fully compacted at the 8-hour portion. So here, these last three, it's considered fully compacted at that point for those regions. And then I'm gonna go back to the previous slide again. So here we have region 1, 2, 3, 4, 5, 6, 7, 8. So here we have the ones that were actually tested for the H3K27 ME3 chip. So with the retinoic acid, it's super low down here for all of these regions. And then, so this is region 1, 2, 3, 4, 5, 6, 7, 8. And here again, we're looking at the relative enrichment fold. So at 2 hours, it starts to increase, 4 hours, slightly increasing, but it's really at the 8-hour mark that it really starts to establish the H3K27ME3. And then it is pretty much done at the 36-hour mark. So between the 8 and 36 hours is where we see that big jump really whenever we're looking at the H3K27ME3 establishment. So it went from 8 hours and complete at the 36-hour mark. So what does all this mean? So this means that the ability of PRC2 to distinguish active chromatin versus inactive chromatin exerts its role in maintenance and not the initiation of inactive states of target genes. And as we saw in the slides, that mutations also cause changes to this. So specifically, whenever we saw these mutations here, that helped us see that, typically the dense is more active whenever it's normal, but with the mutation activation, it's not true. So that's what this study is really talking about, is the distinguishing inactive versus active chromatin and its role in, again, emphasizing the maintenance. It made it very specific that it was not the initiation of inactive states of target genes. I hope this presentation has been helpful, and if you'll have any questions about this study, please feel free to reach out to me. Thanks.